In today's action-packed video, we will introduce the concept of action queries. To follow along, you should log into our SQL Server instance using the personal credentials that were assigned to you. Then you can do what I do. You can create tables and you can do action queries against those tables. Action queries are destructive. In other words, they change the state of the database. You may drop a table, you may delete records from an existing table, you may update data in records in an existing table, or you may insert rows into a table. The reason this is significant is because up until now, everything we've done did not change the state of the database. We merely retrieved information that was there without causing that information to change in any way. Now, things are a little bit different. There's a little more stress in writing an action query because you are affecting a change to the data and the structure of that data. In the real world, there would be a lot more preparation going into creating these queries. We would test them, we would probably have other people test them, there would be a test plan, there would be a lot more design and consideration. We were interested in syntax and execution of basic action queries. The good news is we're playing in a sandbox. Nothing that you do is going to affect any business that's running. This is not a production database, and you only have permission to run action queries against your database. You can't do anything to the AP database. You can't do anything to the animal attack database that we saw earlier. So feel free to write action queries and execute them against your tables in your database. You won't cause anyone any trouble. I am going to give you a script that you can run to create the entire AP database in your database. You can recreate all the tables, and then you can write select queries and action queries against those tables. These are the action queries we will study. We can select into a new table from an existing table, which is essentially copying the structure and the data of an existing table into a new table. We can use the insert keyword to add rows to an existing table. We can use the delete keyword to delete rows from an existing table. We can use the update keyword to change the data in existing rows in an existing table. SSMS does a lot of neat things for us. It's a good tool that we use in production environments quite often. One very powerful thing we can do is to script a table. In this slide, you can see that it is a series of menus attached to the individual table. You work your way down to script table as, and then create, and then new query editor window. I'm going to go ahead and do this for us right now. You don't have this table that I'm going to use, but you can use other tables if you'd like to follow along. And in a moment, I'm going to have you create this table. Right-click, script table as, create to, and you have choices of where to write the script that SSMS will create for you. You can send that script to the clipboard and then paste it into a Word document or an email. You can send that script directly to a disk file for more permanent storage, or you can send it to a query editor window, which is what I will do here. And you can see that it writes some SQL. We're not going to go into all the details of what it did, but suffice it to say that if you run this against your database, it will create the Beyonce song table. All you have to do is replace the name of my database with the name of your database. And then you are ready to go. Then you execute the query. Assuming you have permissions in your database, which you do, you can create that table. Now, instead of asking you to frantically type this in and probably make a lot of typos, as I would, I have provided it for you in the following slide. All you have to do is grab a copy of this, copy, go back to SSMS, and I'm going to clear all these windows. Open a new query window, paste in the text that I gave you, and change the name of the database that you want to target. Once you've done that, you can execute this script and that table will be created for you, which is pretty neat. As a matter of fact, we use this quite often to send a database to a customer. Instead of backing up some binary file on the disk, we generate a script, we send them the script, and they run that against their instance to create tables, views, stored procedures, indexes, keys, and actually even populate some tables. This is a commonly used strategy to send database structure and even data to customers in different places. At this point then, you should have copied that script from the slide, pasted it into a new query window, changed the name of the database, and then executed the script. Be sure that nothing is highlighted when you click execute. As you probably learned by now, if you've made the same mistakes I do, that whatever you highlight is what will be executed when you click the button. You don't want anything to be highlighted. After you've created the Beyonce song table, it should appear in your list of tables. You will have way less tables than I do. But be sure to refresh that table list to allow you to see the new table that you created. SSMS does not dynamically update that tree when we add objects to the database. Click refresh, and you should see these things in alphabetical order. And there's mine right there. Good. You have a table then, and we can do some other things with that table. You can also close this query tab if you like. It will ask you to save the script that you pasted in because you made edits to the contents of that window. You don't need that script. You can always grab it off the slide if you need to go through this process again. As an aside, SSMS can even script an entire database, meaning all the tables, the foreign keys, the relationships, the views, the stored procedures, even the permissions associated with that database. We will also be doing that in a few moments, but we're not going to do that just yet. So it's been a few moments, and I'm going to direct you to Blackboard to get a copy of a script to create the entire AP database inside of your private database. I could paste it on the slide, but it would be hundreds of pages long and it would be tiny and we wouldn't be able to read it and do much with it. So what we're going to do then is we're going to provide that for you on Blackboard. You can download that script, open it in Notepad, and paste it into a query window in SSMS. it is on Blackboard. It's a text file. It's rather large, 139K. It's readable. We could look at it, we could browse it, but what I really want you to do with it is save it onto your local disk. Open it with a text editor. Notepad is fine, WordPad is fine. Copy it into the clipboard. Paste it into a query window in SSMS. Change the use command. And then run it against your database. That will create all the tables that you're used to seeing in the AP database, but they will belong to you. It also populates the tables. All the data that we've seen in previous exercises will be available to you to write action queries. Before you do the homework, if you've made any changes to those tables, you should rerun this script after deleting or dropping all of the tables that you created previously. How do you drop the tables? Use the command drop, D-R-O-P. You can look it up online. It's very easy. Drop space table name. You can clean up all those AP tables and then you can recreate them using this script. Let's look at some action queries in detail. Using the AP tables that you have just created by running the script that we talked about a few moments ago, you can write this command to copy records from an existing table into a new table. SSMS will create the table for you. I'm going to grab this. I will go back to SSMS. And I am going to operate on the AP database for now, but you should be operating on a copy of this database inside your local sandbox. So translate whatever I do into your local database because you ran the script, you created all these tables, and now it's time to have some fun. There's a table called vendors. There's the script that we took off the slide. And when I run this, it tells me 122 rows are affected. Now remember that number, 122. Let's refresh the table folder because the new table does not show up. There is vendors backup. Let's look at the contents of the table. Select top 1,000 rows. And look at the lower right-hand corner. There are 122 rows. It created the table structure, and it copied all 122 rows of data from the old table into the new table. The old table, called vendors, is not affected at all. No rows were deleted from that table. We now have 2 copies of that data. That's your introduction to an action query then. It was destructive. It changed the state of the AP database. We didn't lose anything, but we created a new table with 122 new records in that new table. If I flip back to the slides, let's notice in the following slide, not everything gets copied when you do that select into. The primary key no longer exists in that new table. It's still in the old table, but it is not in the new table. So if we flip back to SSMS again, and we look at the design of that new table, there's a vendor ID, but it is not marked as the primary key. So we could, if we like, manually make that change and then go down and change the identity. Well, the identity specification did get copied, interestingly enough, but the primary key did not. This is not an issue for you when you run the script to create the AP tables. because those scripts do create primary keys. This is only an issue when you use the select into command. Here's another action query. We can update existing records in the database. Now, as you watch the slides and you listen, think about why we would want to do these things, because we're doing them in a vacuum. We've got some data that we don't really know too much about. We're learning the syntax of the commands, but we don't have a lot of context. So think about why these queries are useful. In this case, we're going to update the vendors table, update vendors, and we're going to change only one column in the table. We're going to change the vendor name to William Marvin Electric because Bill wasn't formal enough and he wasn't getting enough work. Only the record with vendor ID 11 will be changed. Adding a where clause then can be limiting on what gets updated. This is kind of scary because we're doing something destructive to our data and we're not quite sure, we haven't built up the confidence to know if we're doing it correctly. That where clause is crucial for us. In this case, it wouldn't make sense to name every vendor William Marvin Electric because we'd all have the same name for every vendor, and that would be very confusing for us and for the vendors. But it is useful to be able to change one particular row when that vendor changes its name for whatever reason. The where clause then saves us a lot of grief from accidentally changing things that we might not want to change. So I can grab this go back to SSMS, let's clean this up a bit, and let's paste in the update query. Update vendors, set vendor name equals William Marvin Electric, where vendor ID equals 11. If we like, we can break this up, perhaps make it a little easier to read. Notice the quotes. The quotes are single quotes. When you copy things from a slide, there may be some font problems. Be prepared sometimes to edit those quotes depending on what PowerPoint is doing on your computer, what fonts you have installed. So a copy of a SQL script from an outside source like a text editor or PowerPoint or an Outlook email may require you to edit some of those single quote characters. You can see that I changed those two single quotes in the SSMS editor and the little squiggle went away because now the syntax is correct. Let's run this. You can run this against your copy of the vendors table in your database. If you're not confident yet, you can add a use command to be sure with 100% certainty that you are affecting the right vendors table. Now that generates an error because there is no your space database in our instance, and I can comment that out. To run this then, I click execute, and at the bottom in the message window you can see it says one row affected, meaning that they've found one row in the vendors table that met the where filter and it changed the vendor name in that one row. I can look at the vendors table, edit or select top 1000 rows. I can look for 11, and there's William Marvin Electric. No Control Z, no undo. It is what it is. Here's a more complex update. I've been told by my boss that every invoice from every vendor in 3 states, California, Arizona, and Nevada, should all have terms of net 10. Now, net 10 does not appear in the vendor table, but the foreign key terms ID does appear in the vendor table. If you don't know what a foreign key is, you need to stop the tape now and go back and review what a foreign key is, or you're going to be lost. We need to edit the foreign key in the vendor table that it defines the terms for those particular vendors. So we're going to need a where clause to limit to California, Arizona, and Nevada. And we're going to need an update that changes the terms ID to 1. And here it is. It magically appears on the next slide. Update invoices, set terms ID equal to 1, where invoice ID in, and look, there's a nested query. Our studying and our hard work pays off. Select vendor ID from vendors, where vendor state in, and you can see there's a typo, California, Arizona, Nevada. So we're filtering the vendor table on 3 particular states, and we're only returning from the subquery vendor ID because that's really all I care about. I'm matching vendor ID. There's another typo. Oh my word. Those won't show up in your slides because you will have the edited version of the slides on Blackboard. Here's a query that has a better chance of working. We've got a subquery that pulls out only the vendor IDs we want, and we match those vendor IDs against the vendor IDs in the entire table. On the matches, we set the terms ID field in those vendor rows to 1. And let's fix this quote. That looks better. I can grab this entire SQL statement and clean up a few unneeded windows. Paste in the query from the slide. Execute that query. Again, if you're not quite confident yet, you can put that use statement in there so you know for a fact what database you are accessing. I'll take that out because I don't need it, and then I can run this. It says 51 rows were affected. Now we're at a point where it's becoming problematic to visually verify that we changed the right rows, because 51 things is a little more than our brain can understand, and we're not really sure what the vendors were that were in California, Arizona, and Nevada anyway. 51 looks reasonable. It doesn't say 10 million, and it doesn't say 0. We have some confidence that we probably got it right. But let's think about a situation where we'd like to be a little more confident that we got what we think we got. What I can do is very easily highlight the subquery. And then I can see that at least the subquery is giving me what I think I'm supposed to be getting. Highlight the subquery, click execute. It only executes what's in the highlighted text. And I can see that there are 80 rows there. According to the return from the subquery, there are 80 rows. We're seeing then 80 total vendors that are in those 3 states. because we ran the subquery by itself and got 80 rows back, we're seeing that 51 rows from the invoices table were changed to terms ID equal to 1. And that makes sense because there are more vendors that don't have invoices. So out of 80, 51 vendors in those 3 states actually had invoices in the table. We've done a mild sanity check on our query. It seems to be reasonable. In a production environment, we would certainly do more investigation than that, but for our purposes, we've done a little bit of debugging and everything appears to look good on the surface. The next kind of action query is insert. In this case, we've been told to add a new item, a new row to the terms table, which is due on receipt, meaning you don't have any term, you don't have any days to hold the invoice before paying it. So we have some vendors that want to be paid immediately, and we need to add something into the terms table to reflect those new conditions when an invoice is received. Look closely at this. We add term description and terms due days into the row. Let's look at the data structure of that table. Flip back over to SSMS. What's in terms? By the way, once you've created these tables in your database, you will be able to open the design pane and look at the structure of that table. Notice that there is a third column in that table called Terms ID that is not included in this insert statement. And that is by design. The design of the table is such that the Terms ID is the surrogate key, also the primary key, and it is set to identity, meaning that SQL Server, the database engine, will increment that for us when we add a new row. Therefore, we don't have to specify a number here. We don't even know what the number would be. Whatever the next available ID value is will be assigned to that new row. Again, we left, by design, we left out the Terms ID column on this insert statement. Why do we do this? Well, one of the reasons we just talked about was that we were given the instructions to add a new term to this table so that customers can, or vendors can, demand that their invoices be paid on receipt rather than giving us 10 days or 20 days. That's a reason. So we might go in and manually execute this query against the database using SSMS and then walk away and have a donut and feel good about what we did. Another reason we would write an insert query is to support other developers in their efforts. For example, this is an eBay page where a listing, an auction, is being added, and I've gone through and configured an auction, or someone has, and they're selling something. It looks very interesting. We should probably all go bid on it. That's a joke, folks. You don't have to do that. But anyway, you get all the way through to the end. You upload some photographs. You pick a sale price. You pick the term of the auction. You pick the shipping conditions. Right at the end, you finally click on the list button. And that causes a SQL query to be executed. Probably more than one. A series of insert statements to create your auction in their database. That's why we do this. We write these queries so that other developers can use them in their desktop apps, their mobile apps, their web pages, their embedded systems. So you are not only learning to do things that will be powerful and useful for you, as possibly a database administrator, database analyst, database user, you are also learning to write queries that will be contributed to the larger code base when you're working on larger projects. And these days, we rarely work on anything alone. It's very odd that you would be working on something with no other interaction with other developers. Projects are simply too big for that kind of effort. You need other people around you. And this is the kind of thing that you will contribute to those other people to help them do their jobs better. So here is a reference to what we just talked about with the primary key in the terms table. We are trying, and I say trying here, to use the value 999 as the terms ID as the next primary key for this row that we're adding to the table. This is slightly different than what we did before. If you flip back a few slides, you can see that we did not attempt to add a value for that primary key. So in this case, we were intentionally saying the primary key for that row should be 999. Now if you look at SSMS, let's again clean up some of these tabs. And hopefully you're following along. Let's look at the rows in the terms table. Yours may not look exactly like this, but you can still get the concept. There are 6 rows in that table. There are not 998 rows in that table. So yes, it's possible that terms ID 999 is still available. We can't say for sure, but it's possible. So our query might work, and the next row added to this table could have terms ID 999. However, if we were to try this, we would get this error message: cannot insert explicit value for identity column in the table terms where identity insert is set to off. What it's telling us there is that the table is designed such that you can't do this. You have to let SQL Server decide what that surrogate key is going to be. Because you configured it as an identity value, you can't go back and change your mind later. What if we absolutely have to have 999 is that new terms ID? What if the rest of the system is so poorly designed that it is already programmed to expect terms ID 999 for 0 days? Well, we go back here and we're not sure. We can look at this design of the table and we really don't see it. And that's because it's not stored here. It's stored elsewhere. So nothing in here tells us whether identity insert is on or off for this table. What we do then is we open up the Google and we search for something that will help us, and we eventually find this. This is authoritative documentation from Microsoft telling us how to turn identity insert on or off. And we're off on a bit of a tangent here, but I just wanted to show you how we might solve this problem. At the bottom, I provided you with a link and that link is to this page that I've snipped here. I will go over to the Google, actually to Chrome, and I will paste in that link. And there's what we just saw on the slide. This is very useful for a couple reasons. One is that it is authoritative, it is Microsoft documentation, so it's not someone guessing as to how to solve this problem. And it provides you with an explanation of what the arguments are to change identity insert on and off. And it also tells you a very important salient fact here. Only one table can have identity insert turned on per session. Session meaning you logged into SSMS, really. So we can turn it off. We can stick in our own custom value for that ID field, and then we can turn it back on again. Moving on then, referring back to the Beyonce Songs table, we all know who Beyonce is. We can use this script to create that table in your local database, and I would encourage you to do that now because we're going to use it in the following examples in the slideshow. So take a moment, copy this script, paste it into a query window, and execute it against your database to get the Beyonce Songs table. And I will quietly hum a Beyonce song while you do that. Alright, that was a fun time. You should have created this table. If I flip back over to SSMS, you can see that I have this table. And let's just verify that it is empty. It has no rows in it. Good. Now we're all on the same page. We will use this table as an example to talk about insert. So in this particular case, as we did in the previous example, we are letting SQL Server, the database engine, handle the ID field, but we are inserting a row into the table. So grab this code, flip back over to SSMS, new query window, paste, and these quotes will need to be fixed. And I can change this to my database. Since I'm actually in my database now, I'm no longer in AP. Actually, my database is something else. And I've got another quote to fix. Run that. Still don't have the quotes right. Looks like I missed one there. And now let's try it. Good, one row affected. Let's look at the Beyonce table. Right click, select top 1000 rows. And there's that row. Okay, we got that query ironed out and it works. We have inserted a row into the table. Next slide. Here I've given you 4 rows, and I'm not going to do this, but I will talk about the slide. Hopefully you are ambitious enough that you will grab these 4 rows, flip back over to SSMS, and execute all 4 of them at the same time. We're simply illustrating that we can do multiple insert statements in one query window. At the bottom of the slide, there's my results. Each insert statement generated 1 message. So I've got 4 messages telling me 4 rows were affected. It added 4 rows to the table. And now there are 5 rows. And there's a reminder about the font problem if you need to fix that. Please keep that in mind. Copying from the slides can be problematic because of those fonts. What I wanted you to do then after you ran it the first time is to run it a second time and get a whole bunch of errors. Now look closely at those errors. A lot of students tend to panic when they see an error message and raise their hand or run away. But you, as an independent online student, are confident enough to read the error messages, take a deep breath, perhaps go to Google and search for a solution. But in this particular case, it's pretty straightforward. You don't have to do a lot of searching. It simply tells you there is a duplicate key. You can't do it. And you probably realize that by running these 4 insert statements a second time, you're attempting to duplicate the song titles. And the error messages are telling you that that is not allowed because the song title is a key and duplicate keys are prohibited. If you want to verify that, go back to the design of the table, right-click, indexes and keys, and the first one, IX Beyonce Song, it says right there that the column for that index is Beyonce Song and it is unique. That means that we cannot have 2 rows with the same song. So we're learning a lot about insert statements, and we're learning a lot about Beyonce, which cannot be bad. If you ran those 5 insert statements, this is what you should see. The IDs in your case will be different. I've run these examples before, so my ID values are increasing. Your ID values will probably be 1 through 5 since you haven't added any rows to that table in advance. Alright, so we've added rows to tables, we've inserted rows to tables, we've updated data in rows. The delete command, pretty scary. You can't undo it. We can roll it back if we have the database configured properly, and if we have the time, and if you have the permissions, but you don't have any of those things. We're kind of in a sandbox, we're playing around, but we still have to have a healthy respect for what these commands can do. I've shown you here in this slide a trick. Very powerful, very useful. Notice how similar the select statement is to the delete statement. It's very easy to write your statement as a select query, run that, make sure it's right, and then edit it into a delete query. In this case, then I've commented out the delete query, I perfected the select query, then I can make sure that they look the same. Very powerful development strategy. Will save you a lot of grief, will save you a lot of coming in on Saturdays to fix problems. If you debug your queries using benign, harmless select statements and then convert them to evil, destructive delete statements. What if you'd like to delete every row in a table? That's almost scary how easy it is. Delete from. You won't get a message that says, "Are you sure?" You don't get to confirm it. Once you run it, it runs. Be very careful then what you're doing when you delete everything in a table. There is no where clause, and you don't get to pick columns. It just simply wipes out all the rows. Deleting a table is even scarier. We use drop, and we just simply reference table as a keyword and then the name of the table. It goes away. No confirmation request, no "are you sure?" The table goes. If your database is configured correctly and you're logging transactions, you may be able to get the table structure back. If you're making backups of the database, you may be able to get the data back. Those are issues beyond the scope of this course. But rest assured that SQL Server is an enterprise-wide database system that is robust, and it is designed to allow you to make copies of things before you delete them. And it is designed to maintain copies of things in multiple locations, referred to as replication, if you have that configured as well.